Welcome back to another episode of Tech Spotlight, where technology meets simplicity. I am Avinash Mishra, your host and friendly neighborhood AI engineer.
And I am Rahul. Great to have you here with us today. So, Avinash, we are diving into something that literally feels like magic, but is pure engineering brilliance. So, welcome to LlamaIndex.
Yes, absolutely, Rahul. So imagine this, you are a developer, a business leader, or anyone trying to build smart applications. You are drowning in data. It is like your data is everywhere, right? Like files, databases, APIs, even endless web pages. A total chaotic mess.
Yeah, it's like a digital equivalent of a library that has been hit by a hurricane, right? So, finding one crucial piece of information is literally impossible because there is so much of data, tons of data, and the data is of a varied type. It's not a singular structured kind of data. And if you're trying to get a large language model, LLM, to understand this chaos, so good luck getting the accurate answers.
Exactly. That is the core problem. And how do you connect these powerful LMs, these AI brains, to your specific messy real world data? That is where LlamaIndex step in. Think of it as
As your AI super smart, hyper efficient librarian. That's the technical definition of it.
precisely. It does not just tidy up with the mess, it organizes it intelligently and fetches exactly what your AI needs when it needs it, providing a crucial context. Today, we are going on a journey from understanding the absolute basics to exploring advanced technology or techniques and even production level strategies.
Yeah, and we promise to make it an engaging, whether you are just curious about AI or you are a developer who is just getting started or you are an experienced architect designing the next big thing, or even if you are a leader who is wondering how this impacts the bottom line. So stick around because basically understanding Llama Index is key to unlocking the true intelligent applications.
All right, so in today's episode, this is our segment one where we will try to understand why part. Why is this llama index is important for you? So it is something like taming the data beast. Let's start at the beginning. Rahul, why can't we just feed all our data directly into an LLM like OpenAI GPT-4 or the Gemini advanced model or any other LLM models?
Right, right. So I think it's a great question, Avinash. So there are many hurdles to why we cannot put all our data directly into LLM. It is something like an equivalent of saying that why can't we take a backup on our RAM rather than taking it on the disk or on a memory tape.
Right.
So the first and foremost problem here is the sheer volume. The data. So any LLM will have a context window. This context window, as we had previously discussed about in our Vector DB podcast, where we were talking about the uh, lot of things into a vector database so that we can retrieve it and augment it for the generation rather than putting entire thing into LLM context. So every LLM has a context window, and this limits on how much information they can process at one moment of time. And this window is very small. We cannot dump terabytes of company data into a prompt right away.
Right, Rahul.
So
It is like trying to explain the entire history of the world to someone in 5 minutes. They will get overwhelmed and miss the important parts.
correct. So this is one. And then secondly, it is about the data privacy and recency of data.
Yes.
So any powerful LLM is trained on public internet data. It is not trained on your company data. Now, if it is an LLM which is done by Google or let's say by OpenAI, they don't know about your internal reports. They don't know about your customer specific database or the credentials. And the other way also, you do not want to give it to them,
Yes.
right? So one thing is that they do not know about your data. Second thing is you don't want to give it to them. The third thing is by no means they are aware about what's happening right now. So if the model is trained and released 6 months back, it knows nothing about what has happened in the world after that cutoff date or whenever the data has been taken.
Yes.
So so the first thing is the sheer volume of it, because you cannot fit everything into the prompt. Second thing is data privacy and the recency of data.
Yes, and thirdly, the structure of your data. Even data comes in all shapes and sizes, like it is from PDFs, even JSON from APIs, text files, database rows, and web pages. So LLM needs help navigating these variety to find relevant information efficiently.
Yeah, and this is where LlamaIndex shines. It acts like a crucial intermediate layer. So
Yes.
you are having your LLM, you are having lot of data which is lying around, voluminous data with a lot of variety. The veracity of data is very high, and this acts as an intermediate layer which can help the LLM or help your system to stitch together this infinite amount of data into your system. So its primary job is basically data ingestion and indexing. So you are having diverse data sources, and the job of LlamaIndex is to connect to diverse data sources, break the information down into manageable chunks, and then create intelligent indexes, ingest these indexes into sophisticated tables of content or map for your data level. So at a very 30,000 feet high level, this is what it does.
Right. So instead of the LLM droning, LlamaIndex provides a curated, relevant snippet of information based on the user's query. It is Retrieval-Augmented Generation RAG in action, augmenting the LLM's generation capability with retrieved relevant data.
So at a very high level, its key benefits would, if we want to categorize its key benefits, it would be threefold. One is connectivity, second is structuring, third is querying. So you are having a lot of data. It helps you to plug in n number of data sources, be it files, API, databases, web pages, you just name it, and it is having some kind of connector to connect to different kind of data sources. Second part is structuring. The key benefit is structuring. So what it does is it takes this data from these diverse sources, organizes this chaos into smart indexes tailored for efficient searching. Third part, you have taken the data, you have indexed, chunked it, you have indexed it. Now what? Query. It enables fast, context aware searches, which is vital for getting high quality answers from the LLM.
Exactly, Rahul. So the impact is huge. We are talking about building semantic search engine that understand meaning, not just keywords. Think of chatbots that can accurately answer questions based only on your company's documentation, or simply making any LLM application smarter by grounding it in a specific up to faces facts. It turns generic AI into your specific AI.
That's the hook for everyone who is listening. So LlamaIndex is not just a tool. It's actually a fundamental piece for building genuinely useful context-aware AI application. When we are talking about using LLMs, it is like having a POC, a demonstrator kind of stuff. But in real life, things are way different. So where these things are way different, this is where the Llama index comes in. It actually bridges the gap between a very powerful AI model and the messy reality of your data. No matter how nice, how powerful your AI model is, your data is too much of garbage, and you have to make sense out of it.
Yes, exactly. So, okay, so we have established the why part. Now let's peek under the hood. How does a LlamaIndex perform this librarian magic? It revolves around a few core components. Rahul, let's start with getting data in.
Yeah. So the first thing is, how do we get the data in?
Yes, yes.
The first aspect would be data connectors. So it is like the librarian's intake desk.
Yes.
You are having n number of things. You are having different kind of books and all that. LlamaIndex provides a huge library of these connectors. So you are having n number of libraries, n number of these connectors, which have the functions that they can pull data from different kind of sources. So you can have very simple ones where you can hook them to read from local files, like you are having text, you are having PDF, you are having CSV, and that kind of stuff. Second type of connectors are the connectors for different kind of databases using ODBC, JDBC connections and all that. That would be under the hood, not right. It would be transparent to the end user. LlamaIndex connectors will take care of it. You have to provide there would be a certain way to connect to a database, and then the database will be available to LlamaIndex.
Yes.
Similarly, there are connectors for APIs, different kind of API.
Yes.
Like, for example, you have to grab weather data, real-time weather data, or some kind of your task from a Notion page, or even that you can actually create something which can describe the web page.
Yeah.
What kind of connectors are available?
Right, Rahul. As you mentioned the web scraping, it is crucial to mention ethical web scraping here. Always respect robots.txt and website terms of services when pulling web data. It is just for, like LlamaIndex helps, but responsibility lies with the app developer. So please, whenever you are using web scraping, use it judicially.
Yeah, actually, the ethics lies with humans. It should lie with humans. The computer cannot be really blamed for not being ethical. So now coming to the next part, you have amount of data, you have written a connector, you have now connection, you have access to the data.
Yes.
Now, once the connector fetches the data, the connector has connected to the data. It has not yet fetched it. Now, LlamaIndex typically represents it as document objects. So every data is like a document object. So we can think of it of document as a container for your raw text or some kind of metadata like source file name and all. So let's say if you have connected to a PDF, all the information of that PDF document, its metadata and its internal content, those would be documents. That would be the container where you can put. So LlamaIndex thinks this object as a document.
But Rahul, raw documents can be huge. You must remember the context window limit, right?
Exactly. So let's say that there is a PDF document which is having 2000 pages. It is humongous. Now 2000 pages, some whatever, like maybe 30,000 or 3 million words is like huge, right?
Right.
Now what LlamaIndex does is that it takes this document. You are having one document which is having 2000 pages, 3 million words. Now what it does is it chunks it down into smaller pieces. And these smaller pieces in the terminology of LlamaIndex are known as nodes.
Okay.
So node is essentially a chunk of text which is small enough to be processed efficiently, but at the same time, it has to be large enough to retain the meaningful context. So we can think of it like if we say human thought process. In human thought process, it is something like a sentence. So a sentence is a meaningful array of words. So just like that, although it is not a one-to-one correspondence, being a machine, it cannot have a variable size of node size and all, but you are having a large enough set of words which will be called a node. It is large enough that it is retaining some amount of context, it is having the meaningful context, but it is small enough so that it does not overwhelm the system. So it has to be efficiently processable. And then these nodes, all of them, so you are having 2000 pages, 3 million words, they are chunked into a number of nodes. Now these nodes, they are also having a link back to original document. Even this part is done by LlamaIndex. Now this chunking process is configurable. You are the one who will decide how large these nodes would be, and the size of these nodes actually determines how much meaning you are able to retain with your system, uh, how your system is going to have meaningful context and how fast it is. So you have to create a balance between that. It has to be fast, it has to be meaningful. So that is a delicate balance you have to maintain, and this is configurable.
Yes, Rahul. So we have a connectors bringing data in, documents holding it, and nodes breaking it down. Now the real magic is indexes. How does Llama index organizes these nodes so they can be found later?
Yeah, so this is where the intelligence lies. So till now, what we have done is actually uh, a slave worker mode. You are having data, you fetch the data. This can be done by like this is routine. You pull the data, then you are given that okay, fine, split it in 20 words nodes, and you split it into 20-word nodes. Do something and insert it somewhere. So this is like the real intelligence of Llama index lies in this next part where you are doing indexing strategy. So Llama index, it offers various indexing strategies. So the simplest one is list index. So list index is very simple. You take a 2,000 pages document, split it in, let's say, for example, for example's sake, you split it into 20 words nodes. What it does is it will take the first one, mark it as index 1 in whatever format it is doing. Index 1, 20 words. Index 2, next 20. Index 3, 41 to 60, and so on and so forth. So this is the simplest type. It is list index. It literally just stores the node sequentially in a list. So, so if I'm fetching the 100th index, it would be 100 into 20 to 101 into 20 kind of placeholder that would be access. So this kind of list is very simplistic. So obviously it would be very good. It would be fast one, and it would be good for very simple Q&A over small documents.
Yes, yes.
So if the complexity is very low and the document size is very small, then it is the way to go. Obviously, the simplest one is for the simplest use case.
Yes, yes. But it is difficult if we have a large data set, probably this won't help.
Yeah,
So
it would not.
yes, yes, yes. So
I
all
mean,
right.
it would start becoming clumsy, giving bizarre results.
Right. Because it's a also like time complexity of linear search is order of n. So if our data sets is very large, probably that would not make more sense for us because then in that case, even the searching of a particular word becomes very, time taking job for us, right? So that's why. So then,
So children are good, children are cute, but they are not for solving complex problems.
yes,
Simple problems, they are.
So in fact, I'm just asking you the next thing is that if this is a very simple and it is only for solving the simple problem, then what are the other powerful, indexes from Llama index?
Yeah, so like the star player for the semantic understanding is vector store index. This is the place where we deviate from the old generation to the new generation kind of shift, where we actually enter into the world of where the power actually unleashes. So this is where the things get really fascinating. What it does is it uses an embedding model. So vector store index is actually it is another AI model to convert each node, the node which we have in the example we took as a 20-word context aware node. Now this chunk of text is actually changed or converted into a list of numbers. Yes. Very similar to what we discussed in the podcast on VectorDB. So it actually picks this node, converts it into a vector. This is what it does. So vector store index is where you pick each node rather than storing it as a index to the actual text. What you are doing is you are having this entire node and using another AI model, it is getting converted into a vector. It is getting vectorized. It is getting embedded as a model.
Right. All right. So audience, If vector sounds mathematical to you, by the way, you can see our first podcast on VectorDB for getting more detail on this topic. So I will put the link in video description. Please go through with that link because that will help you to understand more about the vectors. All right. So let's come back to our current podcast. Can you break that down for the audience? Who are non-mathematician for us?
Yeah, so like in the earlier podcast, we had given a similar example to explain that a vector DB is like GPS coordinate rather than for your address marking. So rather than having an address which is having a definitive structure and for different kind of houses or different kind of properties, you tend to have different structure of providing address. So the address for a school building would be very different from a plot. It would be very different from an industry. It would be very different from a plotted house to a flat in a society. But GPS coordinates, they are always unique.
Yes.
You are having a GPS coordinate, you have provided a GPS coordinate. Once you have done, all this information of what lies there is embedded into the GPS coordinate. So you have to take an address, convert it into a GPS coordinate, and the GPS coordinate will contain this address. So rather than having a complex structure or a varied structure for address, what you are doing is you are having a simple structure, a number, a vector, which is having all this information embedded into it. Here also we are doing the same thing. We are having each piece of text is converted into a unique coordinate or a unique vector. The texts which are having similar meaning will end up closer together in this map.
Yes.
To give again a layman example, let's say that there is a node which is talking about dog breeds, for example. Now this dog breed example, the text which is talking about dog breeds, when we do a cosine similarity with another vector which is talking about golden retrievers or Shih Tzu or Chihuahua, it would be having more similarity than something which is talking about, let's say, quantum physics. Unless and until we are talking about Schrodinger's cat.
So the vector store index stores these numerical coordinates, which is called vector for all the nodes. So let's focus now on the next question. Why is that useful?
Yeah, it is useful because let's say take the farmer example. You are having a very small document, okay, very small text, let's say 200 word text. Now, when you are trying to, let's say you are having a very small text and you are trying to comprehend it, for example, what you would do is you will give this entire text to LLM and with a prompt, which will say, please simplify it in 50 words. And the LLM would do it, right? Now, here the problem is multifold. You are having 2000 pages of document and you are trying to make sense out of it, right? Or you are trying to find out some part of section. You have to search in the entire document, trace out what part of the section is relevant or what parts, multiple parts are relevant, and then make sense out of. Okay.
Yes.
Now, so here what happens is that when a user, so in LlamaIndex, you have taken this document, converted, chunked it into nodes, took out context, and then made index out of it, vectorized it. Now what happens is when a user asks a question, what LlamaIndex does is it converts this question into another vector on similar lines as we have done for the nodes. And it uses the same embedding model. So just like you are having these nodes, which are vectors for these nodes, you are having the vector for the question also. And then what it does is it does a similarity search. So it looks for the node vectors on the map which are closest to this question vector. It is like finding the text chunks whose meaning is most similar to this query.
Yes, all right. That is the powerful then. It goes beyond simple keyword matching. It understands the intent behind the query. And audience, please note that we have covered a complete podcast on VectorDB whose link you will find in the video description. Rahul, we have understood the basic index like vector store index. I believe that there are more different advanced indexes that exist here. Can you explain others also for our audience?
Yeah, there are actually many. So there are indexes like tree index. So that is for the hierarchical kind of data.
Yes.
If you are having a hierarchy and if you want to make sense out of it, those would be tree index. Then there are certain indexes like keyword table index. So there are certain use cases where you want to have a specific key lookup without losing your track on the semantic search. So those kind of cases are for uh, uh, keyword table index. So we will discuss about that in some time when with context. But by and large, this vector store index is often the go-to for semantic searches kind of tasks.
Okay, Rahul. To audience. So, audience, we have our data connected, chunked into nodes, and organized in an index like vector store. The next bit of the puzzle is how do we ask a question and get an answer?
Yeah, so that is the job of query engine. So what you do is you create a query engine from your indexes. So it is like when you give it to when you give this system a query,
Right.
a query that would be your question.
Yes.
The engine uses the index to find the most relevant node using the vector similarity search, cosine similarity, or whatever is the algorithm that is in place. So that's how it works.
Yes. And then does it just give you those raw nodes back?
Yeah, it can, but typically what it does is it introduces one more crucial step. What it does is it takes these relevant nodes, the retrieve context. So you have instead put one query, it has converted it into a similar kind of vector embedding. Using similarity search, it went and searched the relevant node. And then what it does is it takes this node and the retrieved nodes and then it combines it with the original query into a new and carefully crafted prompt. Now this is the prompt which is going to be sent to the LLM.
So LlamaIndex tells the LLM something like this prompt, right? Based only on the following relevant information I found, and then insert retrieval nodes here because the placeholder is there for to insert the retrieve nodes. And then please answer this question. And then there is a placeholder for your query, like questions. So is it they are forming in such a format? Okay.
Yeah, you kind of nailed it. So it is like this. What it does is that rather than giving this entire overwhelming information to the LLM backend, it takes the prompt, it takes then rather than providing it entire context, what it does is it goes around, tries to find out the relevant context from my entire pool of data. Now it is having a sub part of the context. Now you are having a fully formed prompt which can be passed on to the LLM.
Okay.
So this is how it's kind of, if I give an analogy, it is like a front desk. You go to the front desk, it figures out what kind of things are needed and all that. It helps you to fill it gives you a relevant form, helps you to fill it up, and then you go to the main desk.
Yes. Let me summarize the discussion until now for our audience. So, the audience, we have covered connectors, documents, nodes, indexes, and query engine. And these are the fundamental building blocks of LlamaIndex. In the next segment, we will try to understand or we will try to start with LlamaIndex. I would say that getting started, a conceptual walkthrough. All right. So for the developer and architects listening, who is listening today, they might be itching to see the code, see some of the codes, but we won't deep dive into syntax here. But what we do here that the LlamaIndex documentation have excellent, lots of codes, sample codes available. So I request everyone, please go there and take some code and run those codes as a sample after the podcast. So, all right. So let's try to walk through building a simple application conceptually in this segment, right?
Yeah, sounds good. So let's take an example so that we do not deviate into hypothetical, pedantic explanations and all that. Let's imagine that we are building a very simple bare bone a Q&A system which is over a file. Let's say that I'm having my company's annual report. Okay.
Yes.
Now let us walk through from here. What would be the steps?
All right. So first is the environment setup. As like any Python project, you would set up a virtual environment and install a LlamaIndex. You might also need libraries for specific data connectors or the LLM you plan to use as an example. For here, as an example, we consider OpenAI library, but you can choose as per your choice. You might also need other dependencies like LangChain, vector databases, etc., to be installed here.
Right. And then there would be the next step. Once you have set up the environment, you have put a LlamaIndex in place, other stuff. So basically, you have pip install -r requirement.txt.
Yes.
That is done. Next step, it would be loading the data. Now, since you are using a data connector, and here we have said that it is going to be a file. The company annual report is there, so that would be a file. So maybe out of n number of connectors that is provided by a LlamaIndex, you would be using simple directory reader or a simple file connector to connect to this annual report text file. So you will provide the location where it lies. LlamaIndex reads it and creates those document objects that we talked about earlier.
Yes. All right. So audience, so we have completed two steps, right? By now, dependency installed and loading data. Step 3 is indexing. And the audience, this is critical step in your overall architecture decision. This is where you choose your strategy. Let me explain to you with examples. Let's consider semantic question answer as an example where we would likely choose the vector store index. You would tell a LlamaIndex, take these documents, break them into nodes, maybe using a default chunk size like 512 tokens, embed them using the embedding models like one from OpenAI or any like Hugging Face free. I mean, if you want to use open source, then choose Hugging Face model and store these vectors, right? In LlamaIndex handle this process completely for you.
Yeah, so here is the actually critical step. Rather than using a chunk size of 512, if you are using a chunk size of, let's say, 5, you will never be able to make any sense out of it.
Correct.
So that's the crucial aspect. That is the balance. Contrast, if you are going to have your chunk size, which is like, let's say, 50,000 words, 50,000 tokens, it's going to be infinitely difficult and you would need a humongous server to process it. That's where you have to kind of your processing capability and the kind of context you are trying to make out of it. Usually 512 works well in this kind of scenario based on our experience. Now, this indexing step, once you start and depending on the size of the document that you are having, if it is a bigger document, it is going to take some amount of time. But the thing is that it needs to be done only once.
Yes.
So unless and until that underlying data changes, your company report, once it has come, this is one time step to load this entire stuff, create index out of it. And once this index is saved, it can always be reloaded and used based on the whenever you are doing a query. So this is a one time kind of load.
Yes, exactly. So audience, our step 4 is creating the query engine. Once the index is built, as Rahul explained, you create a query engine from it. This is useful. This is very simple. Let me give you a syntax also, but just like one example I'm giving, the query engine is equal to index, which is you created here, index dot, and there is a method which is called as query engine. So once you call it, it returns and store into the query engine container for you.
Yeah. And finally, you have touched the document. You have
Yes.
created nodes out. You have created the document object. You have put nodes in there. You have created index out of it. You have created a query engine. So logically, the final step, querying.
Yes.
So now you can ask a question. Your typical question could be, let's say, a random elementary question. What were your company's total revenue last year, for example? And this is the text. This is the basically the question node, which will be passed to the query underscore engine dot query method.
Yes.
Here the query underscore engine object by doing index dot as underscore query underscore engine. Now that object dot query method, you are going to pass this query string, and
Yes.
this is going to this would actually result in querying the
Right. So the once audience, let me explain to you behind the scene. The query engine takes your question, convert it to a vector, finds the closest node vector in the index, retrieves those nodes, construct that special prompt we discussed earlier, and sends it to the LLM.
And voila, the LLM generates an answer. It is having a full blown context aware prompt with it. So if you are having a very well engineered prompt, it is having all the context, and if it is having the right question, LLM, any decent LLM of modern times generates a good answer. So LLM result generates an answer based on specifically the content of this annual report, which the query engine has returned it back to you.
Yes, it sounds a straightforward concept, and honestly, LlamaIndex makes the basic implementation surprisingly concise and easy to understand. But there are nuances. Let me shed some light on it for our audience. We mentioned token limits and context window. Choosing the right chunk size during indexing is very important. If you go for too small, then you lose the context. If you go for too large, then it might exceed the LLM context size limit.
All right. So LlamaIndex helps to manage this, but it is something developers need to be aware of. So there is another area for refinement, and that is prompt customization. So while LlamaIndex provides the default prompts, you can tailor them to guide the LLM more effectively.
Yes.
So for an example, let us say that you can add some additional information or additional instruction to the prompt. For example, you can add something like, let's say, answer concisely, or you can say answer in 200 words, or you can have something like adopt the persona of a helpful assistant.
Okay, so
Or you can add always answer as you would explain it to a 5-year-old. So accordingly, it will modify the generation capability and provide the relevant answers.
yes. So even in a simple application, there is a room for tuning, which Rahul suggests here. But the core workflow remains load data, create index, create query engine, and then query. That is the foundation. Audience, I hope you are clear with the foundation by now, right? So in the next segment, we will try to focus on leveling up with advanced indexes and integration. Stay tuned, guys. So in this segment,
Okay. Yeah, so in this segment, we are going to discuss about the advanced indexes and integration. So till now, we have covered the basics, the foundations we have covered. Now, just to cater to the people who are having some background in the area, the architects and all, or anyone who wants to build up a little more sophisticated system, Llama Index offers much more than just this basic list of list and vector store indexes. We had discussed some of them, and we promised that we'll come back to this point later. So, Avinash, what happens when your data is having more structure than a simple, what can accommodate in a simple list index or vector store index?
Yeah, great point. Sometimes data is not just a flat list of text or chunks, right? Think of it a book with a chapters and sections or complex documentation. For this, Llama Index offer the tree index, as you mentioned earlier, I believe. So it organizes nodes hierarchically and like a family tree or the file system. This allows for queries that can navigate this structure, summarizing sections or retrieving information based on its location in the hierarchy.
Yeah, and what is the case if the precise keyword matching is important to you, but at the same time you want to have semantic understanding as well.
That is where the keyword table index comes in handy. It extracts keywords from the nodes and builds a mapping allowing for very fast lookup based on specific terms, useful for things like filtering by product names or a specific technical terms.
Yeah, so we have semantic search with vector store indexes, structured navigation for tree indexes, and if we are trying to have precise lookup where rather than keyword it is a text, but still we are looking for a precise lookup, we are having a keyword table index. So we are having these in pockets. Can we have one ring to rule them all?
Yes, we can. LlamaIndex provide the composable index. This is making LlamaIndex incredibly powerful. It allows you to combine multiple different indexes over the same set of documents. You can then query these composable index, and it can intelligently return parts of the query to the most appropriate sub-index or combined result from multiple indexes.
So this leads us to hybrid search. Imagine if you want to find a document that are semantically similar and contain specific keywords. A composable index combining a vector store index and a keyword table index can achieve this, giving you more relevant and filtered result than either of these methods alone can provide it to you.
Absolutely. It is about layering strategies, and this sophistication extends to querying too. So you can implement custom query logic, perhaps retrieving results from both vector and keyword searches, and then writing code to re-rank or merge them based on your scoring rules before sending the final context to the LLM.
And this level of control is crucial for production systems. So now let's talk integrations. So we mentioned that vector store index relies on storing these numerical vectors. While Llama index has simple built-in vector store, what about scaling up?
A very good question. And I'm very happy to share that you can easily integrate with dedicated vector database for large data sets and demanding performance. I am just taking a few names here, but you can integrate with any specialized database like Pinecone, Viviets, Fires, any other also very easily. And so you can easily extend your systems for storing billions of vectors and performing ultra fast similarity search.
So Llama index does not replace this.
Absolutely. LlamaIndex not at all replacing any vector database. It helps to integrate with the vector DB of your choice seamlessly. You can configure LlamaIndex to use, say, a Pinecone as its backend vector store. LlamaIndex still manages the data ingestion, chunking, and embedding process, but it pushes the resulting vector into backend, which is your, in our example, as I mentioned, that is Pinecone. When querying, LlamaIndex asks Pinecone to do the heavy lifting of the similarity search for this.
Yeah, so you need not replace the existing vector databases. You can just leverage their capabilities rather than having its own custom inbuilt database, such vector database as such. So this gives you the ease to use of the Llama index framework combined with the scalability and performance of a dedicated vector database. Now this vector database can be fed up from multiple sources, right? So this is a very standard pattern for a production level RAG system.
Yes, Rahul. So, audience, I hope that by now you are clear about the integration possibility of LlamaIndex and Vector Store. Let's move to another key integration of LlamaIndex, and that is with other LLM orchestration framework. The most famous example is LangChain. Audience, if you are really interested in understanding of LangChain in detail, then you can check our earlier podcast in which we discussed about the LangChain in very detail. I will put the video link here in the description section. While LlamaIndex focuses heavily on the data indexing and retrieval part, LangChain excels at building complex chain or sequence of LLM calls and interaction.
Yeah, so just like vector databases, LangChain is also not a competitor, right? So how do they work together? Can you shed light on that?
Yeah, not at all. They are not competitor. They are highly complementary. You can easily use a LlamaIndex query engine as a tool or a retriever within a larger LangChain agent or chains. Let me explain to you with an example. A LangChain agent might decide it needs a specific information, call out to a LlamaIndex retriever to fetch relevant document, and then use that information in a subsequent steps, maybe feeding it to the another LLM call for summarizing or analysis.
So LlamaIndex helps to find the right puzzle piece from your sea of data, and then LangChain helps to assemble these pieces which are relevant into the complex final picture.
Exactly, Rahul. You nailed it. Using them together allows for building incredibly sophisticated multi-step AI workflow that leverages both private data and context, private data as a context via LlamaIndex, and complex reasoning or action sequence via LangChain. Audience, I'm sure that with the completion of this segment, you are in good shape to understand the core components and advanced concept about the LlamaIndex. You are fully prepared to understand the real world use case scenario in the next segment. So in the next segment, we will pick a real world example and try to understand it. Stay tuned.
Yeah, so let's start with this segment, which is about building the for a real world production and semantic search system, which is production level one. So we have covered a lot of ground from basics to the advanced features. Now let's talk about putting LlamaIndex to work in a real world enterprise setting. So Avinash, your articles detailing building of a production grade semantic search engine, let us use that as our case study.
Perfect.
As an example.
Yeah, perfect. So imagine a large company with a vast amount of internal knowledge document, wikis, reports, and databases. A simple keyword search in that scenario would often fails or it is considered as incomplete response, right? So employees waste hours trying to find information. So our goal is to build an enterprise semantic search engine using LlamaIndex that understand intent and find relevant information across all these sources.
So moving beyond a simple script, how does this production architecture look like?
Yeah, sure. Let me explain. Let me explain to you. And that architecture is layered architecture, which is used here. If you look at the diagram, you can view this as a multi-layered architecture. And the layers are the first layer, which is called data ingestion layer. This needs to be robust. It handles connections to diverse, potentially large scale sources, be it database, cloud storage like S3, maybe even streaming data. It needs validation because the data format is correct or not is very important here. The second thing is it requires transformation because the cleaning data is very, very important to pass further refined information to the LLM. You can use like pandas to clean the data, and a schema management is another kind of useful things to do here. Audience, we have created a video for the Pydantic library specifically to understand how input validation happen in case of you are passing the information to your large language model based AI application. So I put that video link here in video description. If you are interested to know these things in detail, please go through the video. And the next layer is the indexing layer. This is where the LLama index core exists. We would likely use a composable index in this scenario, like vector search plus a keyword search, backed by a scalable vector database. Just an example I'm taking here as Pinecone and these things in running separately because of the scalability requirement. Then come to the indexing might happen asynchronously also because of to achieve the larger scale in the background, right? And the next layer is the API layer. You may ask me why you need API layer, because API layer directly would not require, but we were using here because of our own internal requirement. So we built a secure REST API using something like fast API or class. This API exposes endpoint for searching. It handles authentication, who can search, because we cannot allow everybody can search. Then we can also try to achieve the rate limiting. Why we do it? Because of preventing the abuses. Otherwise, anybody can prevent, it can do the abuses with our system. Then the third thing which is required here is input validation, because many times possible that due to user have their own bad intention, they can query which is not suitable for your system. So those kind of filtering is required in this API layer.
We use API layer because it's a production grade system.
Exactly, Rahul. Exactly, Rahul.
That's the long and short of it.
Yes, yes.
If it was a POC or a demo product, this layer is not needed. But when it goes to production, you need to have authentication, authorization and authentication. You need to have security in place. You need to have rate limits. You need to have caching. You need to have input validation. You need to ensure that somebody doesn't bomb your LLM backend with relentless queries.
Yes, exactly. And the fourth layer, which is we supposed to discuss now, is LLM integration. The API layer, after getting results from the LLama index, might interact with an LLM for summarization or presenting the answer naturally, managing token limits carefully. We need LLM integration. So, as I explained, LLM integration layer is primarily for managing token limits carefully and doing the answer naturally to the as a response. So audience, we are now moving to the next layer, which is monitoring and logging, because we are discussing the production grade system, right? This is very essential in production. You need detailed logging of requests, error, and performance. Audience, for your information, we have discussed very extensively about the LangSmith uses for these monitoring purpose. So apart from Prometheus and Grafana, which I mentioned, I am going to mention here, like monitoring API latency, query speed, error rates, and resource uses. You can also use LangSmith as per your requirement or to monitor the logging, especially monitoring and logging purposes. Now, another one thing is like, because this system becomes a distributed system, so one tool which is very useful in case of distributed system, which is called Jiger. Jiger is one tool which is useful to trace the distributed system. So audience, we are now moving to the next layer, which is deployment and security. And by the way, this layer is very useful if you are building anything and going to the production grade system. Right? Moving to the production.
The first four layers are part of this ecosystem.
Yes.
The these layers, monitoring, logging, and deployment and security, they are kind of across the layers.
Yes.
So
yes.
you have to ensure that there is monitoring, there is logging, there is deployment ease and security across these four layers.
Yes, you can say that this is a vertical component which can be applied to most of the other component, right? So the entire application needs to be deployed reliably. Containerization using Docker is a standard. This allows you to package the API, the LlamaIndex components and dependency consistently. You would deploy these containers to cloud platform like AWS ECS. Maybe you can choose Google Cloud Run. Maybe you can choose Azure Kubernetes services. And also there is an infrastructure as a code like Terraform helps manage this much better. Security is paramount. Protect API keys using secret managers like HashiCorp, Vault, or any other cloud services. Use HTTPS, handle authentication properly, use as JWP is the advanced system. So use that, possibly you can use it. And then sanitize all inputs using the Pydantic library. So audience, I hope you are almost ready with all the concept required to use a LlamaIndex. Also, please use video links for exploring more detailed analysis on these subtopics as I mentioned.
Okay, so that sounds significantly more complex than our simple script. So can you highlight what would be some of the key best practices while implementing this?
Great question, Rahul. So, although many best practices can be followed, and if and listing all the best practices is not easy, or it is not advisable here. So we will choose few of them, and we will try to explain you what are and how these are helpful for creating a production grade application for our audience. The first best practices is we have to create a use modularity for our application development. What do you mean by modularity? Let me explain you. So modularity is simply like keep the layers separate. As an example, changes in the one layer, say for example ingestion layer, should not break the other layer, just example API layer. So if there is a change in ingestion layer, it should not impact negatively to any other layer. So that is one thing. That is modularity. So we have always considered modularity as we should always consider modularity in our application development whenever we think about the production grade. Next is configuration management, right? Most of the time in application, we have lots of things which is configurable. We should avoid any direct static, hard coding in your code. So that is the next thing which I am discussing here, that usually we should avoid any such things in production. So if you have used any such kind of, a hard coding or maybe a static linkage in your code, then please remove it, because that is not going to work well for your application in longer run. So in production, definitely no to such things and use proper configuration management. All right. The second is, third is testing. We people as a developer have a tendency to avoid, not use testing so extensively, but that is not good in case of production system. In production system, we must have to use unit test very extensively for testing the individual function. Maybe integration testing they have to use while testing the component interaction, right? Then they can
We should be using TDD as test driven development rather than testing driven development.
Yes, exactly. As you mentioned, TDD is test-driven development is also a very good practice to follow. So that is what you mentioned is correct here in this scenario. Another is, since LLM-based application have one very specific requirement is performance. You have heard about it. Audience, you must heard about it, that performance is one of the key criteria for user to use your smart application or any application, whatever you are building, right? So always benchmark indexing speed and query latency in your application. Optimize chunk size. Do the R&D to do the things like how you can get or how you can improve the performance. As Rahul mentioned earlier, that even in the simple application, there are lots of scope to fine tune. So to use that concept, I am just saying that performance tuning is also one of the criteria or best practices in your production grade application. Then the next is ethical AI. Responsible AI and ethical AI is the buzzword, which is definitely you have heard about. And this is not only buzzword in the sense of this is very highlighted, but in my sense, this is very, very essential. Whenever you are building any application which is based on AI or in especially in our case like generative AI, we must have to check regularly, audit search result for biasness, especially if dealing with sensitive data, ensure compliance with privacy regulation, because your user is using, I mean, all set of kind of user is using your application. So you definitely ensure compliance and privacy regulation. These are only few. It is not only this much. There are extensive, I mean, in general, you have to make sure that your application follow proper guidance of ethical AI.
Right. So actually, ethical AI is very, very important because unlike other places where you are providing some data from some kind of source, here since the data and its presentation or its analysis is getting generated, so it doesn't lie anywhere. There is no way you can actually do a cross checking without putting human intelligence.
Yes, yes.
So since this is kind of getting generated, if it is having some kind of sensitivity or some kind of bias against a particular line of thought, there is something which will be churned up by the system without any scope to actually validate. Because technically, generative AI can lie. So that is the problem.
Correct.
Whereas your normal system does not lie and until your the business logic is not altering the information, the computer cannot lie. But here it is not the case. If there is a bias that is built into the LLM model or during ingestion or whatever, you are going to have something which would be a lie, and that would be with a kind word wrapped as the LLMs do with lot of thank yous and for your informations and good mornings and thank yous. This is actually dangerous.
Correct.
Yeah, so this actually highlights that building a production AI system is much more about robust software engineering and ML ops principles as it is about the core basic kernel of the AI technology like LlamaIndex.
Exactly. So LlamaIndex provides the powerful engine for the data part, but building a reliable and a scalable and secure system around it requires a very solid engineering practices. The semantic search engine, like we discussed here as a MVP, would likely be the core API endpoints, perhaps with a simple UI like you can use Streamlit demo mentioned, and for user to interact with. Like this application is very simple, but somehow it is useful if you build a running model, complete running model, and follow the best practices to achieve the application grade, best grade of application, which is a production ready for your, I mean, use case.
Right. And then there would be business value associated with it. It would be you would have faster information to access faster access to the information. You would have much reduced employee frustration. You would have better decision making based on comprehensive data. You would be having you would potentially be powering customer facing support bots, which is normally not the case unless and until you are actually putting a human. Otherwise, it results into very weird kind of responses from the support bots. So even in terms of the business value, the ROIs can be really significant with these kind of systems.
Yes, exactly, Rahul. So, audience, we have reached now on our last segment, but definitely this discussion opened many ideas, a real use case for you. Stay tuned. So, we have covered a massive amount today, from the fundamental why of Llama Index to the complexities of production deployment. Let's quickly recap the key takeaways.
Yeah, so we have covered the why, we have covered the what, we have covered the how. So for it would be in this section, it would be mostly around what next. So for beginners and the business leaders, the main point is that the Llama Index is the crucial bridge which connects the powerful but the generic AI, the generic AI model to, and it converts. This bridge act is the one which converts your powerful but generic AI model to your specific AI model, which is having the data which is private to it. It is not sharing the data to the rest of the world. It is keeping the data to itself and yet using the power of the AI model, which is generic.
Yes.
So, in effect, it acts like a smart librarian which can have books on the display, as well as it can have its own private collection of books, which it would be able to provide in a which it will be able to unlock based on accurate and context aware answers. So in effect, it makes AI, generative AI in particular, relevant to our world.
Yes. So for developer and architect, getting started, focus on the core components like connectors, documents, nodes, indexes, especially vector store indexes and query engine. Understand the basic load to index to query workflow and then importance of managing LLM context window.
And for experts and architects designing relatively complexer systems, remember the power of advanced index.
Yes.
Which is tree, keyword, composables for hybrid search, the necessity of integrating with vector databases for scalability, the synergy with frameworks like LangChain, the critical importance of production based practices like robust engineering, security, monitoring, testing, and so on and so forth.
Yes. The field of RAG and tools like LlamaIndex is evolving incredibly fast. So audience, you always have to go standard documentation section of LlamaIndex and check what kind of progress or current state is going on. We are seeing advancement in embedding models, more sophisticated retrieval strategies, better evaluation frameworks, and tighter integration across the ecosystem. Keeping up requirement, continuous learning.
What is exciting is that these tools are becoming more and more accessible and more powerful as the day passes. So they are enabling even smaller teams to build applications that were kind of straight out of a sci-fi movie just a few years ago.
Absolutely. So if this has piqued your interest, audience, if it piques your interest, dive into the official Llama Index documentation. It is fantastic. It is very helpful. So go and check it. Try the code examples. Join the Llama Index Discord community. That is also very active and helpful.
And needless to repeat, but still I will repeat as I've been repeating in all the podcasts.
Yeah, exactly.
Just do the examples. Just start simple, understand the concepts, then gradually incorporate the more advanced features as your need grows. That's
Yeah.
how it works.
Yeah. Yes, Rahul. So thank you all for joining us on Tech Spotlight today. We hope this journey through LlamaIndex has been insightful and empowers you to build a smarter, more context-aware AI application.
Yeah, so until next time, keep coding, keep exploring, keep connecting that context. I'm Rahul.
And I am Avinash. Take care, everyone. Bye. Take care.